Welcome to another bonus episode. You definitely should watch episode 27 first on everything that has to deal with running reverse traffic. But I talked a lot about manual blocks, and I gave an example from Willow Creek to Almonica being a manual block. I'm going to give a few other examples of manual blocks, and I'll give you some non-examples of what are not manual blocks. Burnside Street is interesting. Now, I've talked about it before, but Burnside Street uses mass detectors instead of call loops like the rest of the system. Now, a call loop is a gray box in the rails, and your train pulls up to it, and you call the signal like normal. It requires an input from the operator. They have to press the button in their cab when stopped over this in order to call the signals. You probably know that already if you've already watched the episodes. But mass detectors, which are found on Burnside and a couple of other areas, function completely differently. They don't require any input from the operator. All you have to do is pass over them. And the weight of the train itself is what activates them. So if there's a train on the tracks, it will detect the weight of it, and it will automatically call the preempt signals for all of the rest of your intersections all the way to whenever. So mass detectors are used on Burnside so that you don't have to use call loops at all. You don't have to stop at the stations. The major downfall with mass detectors is that they only work for trains traveling in the correct direction of travel, running forward traffic. But for trains that are running reverse traffic, you're going to be on the other rail, and when you're in a manual block, you're going to be running in the wrong direction. And so for trains that are, the mass detectors only work if you're traveling in the correct direction. So that means that you're going to have to stop and SOP the intersections, which I've talked about before. And because these are included in train orders or whatever, you'll already know that. And instead of having to give permission to SOP the intersections, well, that part will be included in your instructions. So that's the nice part about this, is you don't have to call in for permission to SOP the intersection. You can just stop at the intersection, wait for a fresh green traffic light with the parallel walk symbols, and make sure that when you do this, that the left turn arrows on the intersections are also red. You don't want to be going forward when cars have a green left turn arrow. So you got to wait for a fresh green parallel traffic light and make sure the turning signals for those lights are red, because again, you don't want to be going while cars are turning right in front of you. So yeah, they have it to where the SOP action is built in, but you just got to remember that. So if your train order has anything to do with running reverse traffic, sometimes, many times, depending on where you are on the system, but let's say it's Burnside Street, well, that's it. There's no way to call the intersections properly, and so yeah, you're going to have to SOP the intersections. And again, just a brief reminder of what that means is you stop at the intersection, wait for the fresh green light and walk signals, sound 2 horn blasts, and proceed to the next intersection. Now let's go over the Robertson Tunnel. Now I kind of briefly touched on it last time, but let's go into more detail. So let's say the westbound tunnel itself was closed. Let's say they were going to be doing maintenance, electrical maintenance or something. So the westbound tunnel is closed. So trains traveling eastbound will use the eastbound tunnel. Duh. It's just the eastbound tunnel. So it'll run like normal. And in fact, because it's an isolated tunnel, there won't likely be any reduced speeds either. So you'll be going pretty quickly. There might be a speed reduction by the pocket tracks at the west portal. There might be, because trains will in fact be using that. But throughout the tunnel itself, you're pretty much going to be hitting a decent speed through there. So then you stop at the station, and then you continue into Goose Hollow like normal. So the eastbound direction of travel is pretty normal. Now if you're a westbound train, if you're leaving Portland, then you will have to switch over to the eastbound tunnel. So on the west portal, there's a pocket track for storing trains, and it also doubles as a place to turn trains around. And in the east portal, on the eastern side, on the Portland side, there's a double crossover of tracks, so trains can get onto either rail. So on both ends of the tunnel, there are ways of getting trains onto either track, which makes this process so much easier. So if the westbound tunnel is closed, then obviously you can't enter it, and so you will be switching over to the eastbound tunnel bore, and you'll be running through there. And again, the speed limits are pretty much the same as in the westbound tunnel. So you'll still be able to hit the high speeds. But when you serve Washington Park, the doors will actually open on the right instead of on the left, because you're going to be in the other tunnel bore. And so that's going to be a bit interesting for passengers. Board trains in both directions on the same platform. They actually did that a couple of years back, but they only did it at night. I would check the PDX bus app on Detours, and it said every night for the next few days, the westbound, I think it was the westbound tunnel bore was closed. I don't remember what they were doing. And so yeah, this process would have been done, but it was really late at night, and by that point I had already probably been going to bed. So I wasn't able to go out there and go see any of it. But and getting back on topic, because what? Westbound trains will then be able to hit a 55-mile-an-hour zone. Remember how I talked about dwarf signals? There are no dwarf signals in the tunnel. They just show normal red, yellow, green signals in both directions. So you can shut down one tunnel bore and still have trains traveling in both directions. But you will have to slow way down at the west tunnel entry. So yeah, it's going to be a little weird, because normally when you're traveling in the westbound tunnel, you can hit crazy speeds the whole way to Sunset Transit Center, really. But during this, you're going to have to slow way down at the edge of the tunnel, because as soon as you exit, you're going to have to switch over into the pocket track and then switch again into the westbound main line, and only then will you be able to resume the 55 miles an hour you were doing before. But let's say the eastbound tunnel were closed. Well, again, westbound trains are going to be pretty much unaffected. They'll enter the tunnel from Goose Hollow and go all the way through without being affected at all. But eastbound trains, because the eastbound tunnel is closed, will have to switch into the pocket track. And I didn't really mention this, but there's a certain route code that'll get you into the pocket track, and then there's another route code that you'll set to get into the other tunnel bore, and from there it'll switch you over into the westbound tunnel when you're traveling east. And again, because of the speed limits, you're able to travel at pretty much the normal speeds. And it even, you know how when you're traveling through the tunnel, it's slow, you have to slow your speed down near the end, because there's a speed trip magnet, because when you enter Portland, you're supposed to be going 20 miles an hour. So what happens is, when you're going that speed, that is true in both tunnel bores. So both tunnels have a speed trip magnet set to 20 miles an hour when you're about to enter Portland. And so you'll be doing much the same thing there. It's just that you're in the westbound tunnel. So really, it's basically just like riding through the tunnel like normal, but you're on the other side, which would be very interesting. I don't have any video proof of this. Here are non-examples of areas where dwarf signals may be used and manual blocks, and it's a little bit different, and it's stuff that we haven't talked about yet. And that's for the tracks at the Fair Complex or Sunset Transit Center or some of the turnbacks on Interstate Avenue. Those turnbacks are known as time lock switches, and we are not talking about those. Those are going to get their own video later because it's really weird. They might be used to start manual blocks or whatever, but it's not like if I'm sitting at Sunset Transit Center eastbound and I want to get over to the westbound tunnel bore, setting my route code at Sunset, the signal will display a secondary route. I believe it's yellow over yellow, and that does not mean I'm going to switch over the tracks at Sunset, even though they're right there immediately after. No, that yellow over yellow means that I'm going to be switching into the pocket track right by the tunnel entrance. And the reason is because the switches immediately at the Sunset Transit Center are time lock switches and are not connected to the signal equipment. So it will not be able to do anything like that. So we're going to talk about those at a later date. So those are non-examples for now. But Willow Creek Transit Center, the example that I gave on the last one, well, Willow Creek was originally designed to be a terminus. So yeah, it can function like a normal terminus. So you can, at El Monica, you can call the signal and it will either display just a single clear signal, or it'll give you two aspects on your signal, which means you're taking your secondary route, which means it will switch you over to the left track at Willow Creek. So you remember all those signal videos that I did bunched together? Well, I'm going to do another one sometime in the future for switches. So there's going to be a long series on switches as well, and that's when we'll get into everything. But for now, this bonus episode went on way too long, so for now, that's going to be it.